Good day everyone, I'm Yankee Oscar 6 Delta X-Ray Echo. Welcome back to DX Explorer for another video. In today's video we're going to do a kit build. I have here the RF amplifier from QRP Labs. It's a 50 watts RF amplifier designed for CW. It's not mine, it's my friend's Vlad, Yankee Oscar 5 Bravo Delta Lima, and he sent it to me months ago to build it, just because he didn't have the equipment that he needed to do all the measurements and verify to make sure that everything works fine. And I have to apologize to him because I delayed so much finishing this amplifier, just because as you all know, I've been crazy busy doing other things. So yeah, I finally got to it. We're going to finish it today. It's my first time building an RF amplifier as well, so I won't show you step by step the way I'm building it, but I will stop in the parts that I think that they might be a little bit confusing, not just for you but also for me, since it's the first time. But I hope it will turn out okay and it works fine, and then I can finally put it in a package and send it to Vlad so he can have some fun on the 20 meters band with the QCX Mini, which is a great transceiver. I've been listening to it. I'm not transmitting because I don't know the code, but I like it very much. I like the sound. I like in general all the work done by Hans. He's doing great stuff over there. So anyway, I'm not going to waste your time. You will find the instructions for how to build this amplifier and also the page where you can purchase it. I'll put the link in the video description down below. By the way, you can also order, I believe it's this is optional, you can order the enclosure as well. It comes with a really nice enclosure and I would really recommend you to do so. And yeah, you should be able to put it together in no time, and I hope I will do the same. Talking about this RF amplifier, I wanted to write an article about this one for a long time in the radio magazine, because I had a lot of people asking me why I deleted the blog, the DX Explorer blog, and where they can find the articles now. Well, most of the articles that I used to have on the blog, they were also published in the radio magazine, which now is translated in English slowly, because we're not longer publishing articles in Romanian and any new numbers of the magazine, at least not for the moment. But yeah, if you feel like ordering a number, it's a digital version. It comes as a PDF. I'll leave a link down in the video description as well. It's on the Raw Waves website. So yeah, my friend Andre, Yankee Oscar 6 Tango Juliet is taking care of this. So yeah, you will find most of my articles over there. And I know I had a lot of emails lately, many of them, asking me to bring the blog back. I will think about it. It's not a promise, but you have to realize that for me, all that I do in here on the channel and what I used to do on the blog is just a hobby. It's what I do for fun, to enjoy the hobby, and I really like doing this and spending time working on circuits and experimenting and learning, because everything is a learning process to me. But unfortunately I cannot make a living out of this, so I have to concentrate myself doing other things so I'm able to actually make a living and pay my bills. I mean, I know I'm getting some money from YouTube for the advertising that you see on the videos, and it helps me, but it's not even paying my electricity bill, so you can imagine how much money I make from that. And also, of course, I'm getting some money from the sponsor of the channel, from PCBWay, but still it's very little, and it's not enough to pay the bills. So I have to concentrate on that to make a living, on other things, and this is just for fun. And yeah, who knows, maybe later on in the future, when I have more subscribers and more views, hopefully I'll be able to make a decent living out of this, and this way I will be able to put more time into this and concentrate more on this rather than doing other things. But yeah, for now this is it. So it's not a promise I'll bring the blog back, but I'll try. We'll see, depends on how much free time I have. Anyway, let's not waste any more time, because this video might turn out to be quite long. So let's get started and put this kit together, see how it turns out. I usually start by soldering the end connectors, and I make sure they fit on the end cap of the enclosure, and it's all good here. When you're soldering the big resistors, just pay attention because they're quite big, and be careful at the very ends, the tips of the resistors, so you make sure that they don't touch each other. Okay, and this is how far we got building the amplifier. I left the inductors at the end, even though in the instructions they have a different order, but I would really recommend you to actually follow the instructions in the PDF file. I just have my own way of doing things always. So first, again, I started with the connectors, just because usually I have a problem with the connectors. I never managed to get them to fit with the end part of the enclosures in my builds as well, not just the kits. So yeah, I soldered everything, and all I left for the end, it's all the inductors for the low pass filter, the transformers and so on, and the two IRF 510 transistors. I have this one on the back. I'm not sure how well you can see it. This is the way I soldered this one. It fits perfectly into the enclosure. I'm always checking before soldering. It goes in very, very nice. There's enough space over there. On the LEDs, again, let's see if we can zoom in a little bit. So this is the way I followed the instructions, and I soldered the LEDs. I don't have to leave any space from the bottom to the top. And once I placed the end cap, even before I soldered them, I wanted to make sure that they fit in the right position, and after that I soldered them. So I'm ready. Now all I'm going to have to do is to wind the toroids, and we'll do that right now. And of course we're going to finish putting everything together. By the way, the PCB board, when it comes, it has these two ends. You will just have to remove this one. Basically you just break it. So yeah, okay, we're ready for the toroids. Before I continue, I think I forgot to mention at the beginning, the board also has some SMD parts. You have nothing to worry about. You don't have any headaches because you have to solder SMD parts. They all come pre-soldered, so they are already installed on the board. You don't have to deal with that. You just have to solder the bigger components, the through-hole components basically. So yeah, I have to admit that the kit is very well made and very well designed, and also the instructions are so well written that there's really nothing special to talk about in here, because if you're following the instructions that you have in the PDF file, the ones that you download from the website, they are so well written that if you make mistakes, it's your own fault because you didn't pay attention. It's really, really well written. So even as a beginner, if I was the beginner a couple of years back, I would say that I could build this amplifier without any problems. So far it went well, and yeah, just follow the instructions, pay attention, measure all the components to make sure that you put the right value in the right place, and yeah, you should be fine. I mean, there's really nothing too hard to this kit. Alright, so I'm going to start with the inductors required for the low pass filter, because they're the easiest to make. And by the way, depending on the version that you're building, you might end up with some leftover capacitors. So these were not required for the 20 meters version. In the package you will receive everything you need to build it, depending on what band that you're choosing. So anyway, I'm going to start winding this toroid. So each time the wire goes through the toroid, that means it's 1 turn, and L6 is supposed to be 14 turns. It's written over there, 0.904 microhenry. So we have 2 turns. We're going to measure it with the LC meter. 14 and 15. I might take 1 turn out, but I rather have 1 turn more and see if I have the required inductance. If not, I will just take a turn or 2 turns out, because I noticed that the inductance will depend on the manufacturer of the toroids, and they might vary. Sometimes you calculate 14 turns and the inductance is too little, or sometimes it's too big, and you might have to do adjustments. So that's it. I'm just going to take the insulation off the wires, and we'll make a measurement on the LC meter. So 14 turns, this one is ready, good to go. Let's measure it and see what's the inductance. Alright, so I connected the inductor, and right now it's showing me 0.93. So I'll just spread the turns a little bit, probably to try to lower the inductance a little bit, because into the manual it says 0.904, so basically 0.9. But yeah, so what I did, I had to remove some turns. I'll just leave it like this, should be okay. I had to remove some turns, so instead of 15, I didn't use 15 turns as I did at the beginning, but I didn't use 14 turns either. I'm using 13 turns right now to get this inductance, and basically from the manual I will use the inductance rather than using the number of turns, because this might vary depending on the toroid, depending on the manufacturer usually. So yeah, I'll just stick to 13 turns, and I'm going to solder this one in place, and after that we're going to continue with the rest of the inductors. Alright, so L6 is in place. I'm going to continue with L4 and L7, and because it's the same process basically, I will wind the inductor, measure it, place it on the PCB board, and after that I'll get back once I start winding and soldering the transformers. For now it's easy job. I hope I'm doing right. The fact that I'm because I'm confused now, you know, you always start asking yourself questions, but I hope I made the right choice, picking to choose the right inductance that I find in the manual rather than the number of turns. So yeah, I hope I'm doing good. We'll see when we measure the harmonic suppression on the output. Anyway, let me carry on with the rest of the inductors. Alright, so all 3 inductors are in place right now, the ones for the low pass filter. So now we only have left the 2 transformers and to solder the transistors, and we're done, ready to do the tests. And hopefully it will not get in fire. So we'll have to do the smoke test. These 2 inductors, by the way, in the instructions they're supposed to be 13 turns, and the measured inductance 0.773 microhenries. What I did, it was 2 turns, and I measured somewhere around 0.78 microhenries, so I'm pretty close as I could. Okay, time to do the transformers right now. So right now I'm preparing the wire for T2, the transformer. Basically I'm just twisting the wires together trying to somehow get some angle at 45 degrees between the wires, as equal as I can to the entire length of the wire. And I should be ready in just a little bit, and then we're good to go to wind the transformer. Okay, so one thing that I like doing before winding the toroids, but it's usually only on this 43 material or similar, I like to scratch the edges with the pliers or cutter, whatever this one is, to remove any imperfections on the toroid that might scratch the wire, and then I want to end up having some short circuits, which I don't want. Okay, so this should be all right. Now for T2 we're supposed to wind, I believe, let me see, 10 turns on this toroid. So we're going to wind 10 turns. I'm not going to do it on camera because it's difficult being two wires, but just make sure you wind them as tight as possible. You leave about 4 or 5 centimeters at each end. It's written into the manual, and I'll be right back when it's done so we can continue and solder it to the board. Alright, so the transformer T2 is done. This is the way it looks. Now I believe I have to find out which end it's which. Scratch the insulation from them and solder it to the board. So I guess let's jump on the multimeter and find out what we have to solder and where. I'm going to have to read the instructions as well, because I have no clue what to do with this one. It's fun. By the way, this is only the second time I'm winding a transformer with twisted wire. I think the first time I did it when I built the simple direct conversion receiver that I posted some while ago, and I had to wind the transformer for the mixer. Interesting. Okay, so I have my trusty multimeter over here. Let's figure it out. So this is the beginning of the coil, these are the end of the coils. Trying to find out which one corresponds to with which one. So these two are together, these two are together. So I have to have a black mark, put them on diagonal apparently, as it shows in the schematic. So I believe this should be this one. I'm going to mark this one with a black marker. Okay, and let's double check. I believe this one. Okay, this was the other one, and apparently we have to have them in diagonal. So that means I have to unwind this, and now I have them just as they are in the drawing from the manual. Okay, I have no idea how to put it on the PCB board, just because the way it is right here. Okay, in one side I will have the wires. I don't know how the wires end up in the other side. Maybe underneath the toroid. I have no idea. Maybe it goes like this. I don't know. I need to check the manual carefully until I figure out the position, and then I'll be right back to share with you how it has to be installed, because right now I'm lost. Okay, so I think I got it figured out, even though the position of the terminals on the PCB board is just a little bit strange compared to the transformer, but hey, I know how it is when you design things, because it's not always easy to fit with the rest of the circuit when you have strange inductors and transformers and so on, RF coils. So let's see if I got it right. Okay, so it's like this. Apparently in the manual it says that one black wire that comes over the outside of the top of the toroid must be inserted in the hole nearest Q2 next to the PCB, the top left hole. So it's this one over here. This is Q2, this is the black wire. Okay, I got this one right. Now it says from the top, but I had to put it through, basically it's through the wire. Still 10 turns, I didn't change. 1 2 3 4 5 6 7 8 9 10, right? And then the second wire, the non-white wire from the same top side, it goes into the other side next to C6 on the PCB board. So we got this one right. And then the other side, it's easy because it's exactly the opposite. The black wire comes over here next to C7, and the non-black wire comes next to Q1. So right now I'm going to have to take it outside, scrap the insulation from the wires, place it down on the board, arrange it to be very nicely placed, and then solder the transformer together. So I'll do that just now, and I'll be right back. Alright, so I'm going to double check one more time with the multimeter to make sure that I have black and black, and this is white and white, so basically not colored. Alright, so I installed it properly. Now I just have to solder it. So I think this is the only little thing that I found about this kit. I don't like the placement of the terminals because it's just counterintuitive. Basically you have both windings that they end in the same side because you have 10 turns, so it would make sense to have something similar like here. Basically this is T1, so it would be nice if it was something similar to this one, but right now the wires are very strangely going underneath, if you can tell. So basically it comes from here, which is this side over here, and they go underneath, and it comes out in the other side, and then this one comes over here and is stretching. It's just a little bit strange, but anyway, it is what it is. I'm going to solder it this way. Okay, so I finished soldering the transformer. It's in its place, all good. Again, very strange positioning of the terminals, but it is what it is. I cannot change the design of the PCB board, but it's very strange placing indeed. So these wires, they come from the top over here and this side, and then the other wires, which basically they come from here, they go underneath and they come back in this side over here. Very strange, but anyway, that's it. Okay, I'm done with this one. Let's make T1 right now. I'm not going to finish this one because it's basically the same process like T2, except that it's with 3 wires. So I'm going to twist 3 wires, wind the toroid, and then we'll come back and figure out which wire goes where, and solder that one in place as well. And then we have one more left. Alright, this one I placed already on the PCB board. I haven't soldered it yet. I'm just warming up the soldering iron on, but this one it's a lot easier to place on the PCB board, just because of the position. So over here we have the beginning of the coil, and here we have the end of the coil, and the terminals are very easy because they're in order. So here we have the beginning of, let's say, coil number 1, this is the beginning of coil number 2, the beginning of coil number 3, and over here we have the ends, so it's the end of coil number 1, the end of coil number 2, the end of coil number 3, so they are in order. So that makes it very easy to place it on the PCB board. And yeah, but pay attention, make sure you measure with the multimeter so you have continuity and the proper order between the wires, and also you can double check to make sure that you don't have any short circuit between any of the wires. And now that it's all done, I'm just going to solder it, cut the terminals, and we have one more transformer to wind, and we're done with the amplifier. We can start testing it, and hopefully there's no smoke coming out. Okay, now it's time to show you the final transformer. So I have the beginning over here, this is the primary, it goes one turn, and then you have the second turn, and after that we're going to move on the other side, and here we're going to have 3 turns. So we have basically going with the wire through one time, and then the second time, and after that we'll go again a third time. And that's it. This is the secondary. It's very easy. I glued with super glue the toroids together, so basically it became some sort of binocular. And to make sure that I don't mess up which one is the primary, which one's the secondary, I ended up bending the end of the wires on the primary, so I know that one is the one with 2 turns. And now it's time to solder it to the PCB board. So I placed it in its place. The primary will be soldered in the side of the connectors, and the secondary will be in the side of the toroids, basically the low pass filter. And yeah, that's it. It's very easy. Just for you to have a closer look, this is the way it looks. Okay, so we're almost finishing the amplifier. I was about to say audio amplifier. Now from what I read in the instructions, I finished soldering everything but the IRF 510 transistors, and that's the complicated part, trying to put everything in the enclosure as well. So it's all in place, all the resistors, all the capacitors, the transformers, the inductors, the big transformer. I'm just going to clean up the board a little bit and then brush it so it's clean, and after that the next step it will be to basically place this one inside the enclosure. One thing I noticed, make sure you somehow push this toroid a little bit inside so it won't touch the metal of the case, just in case. And make sure you always cut the terminals of the components on the back as short as possible, so you don't have any surprises that you will do any short circuit on the enclosure or anything like that. Now, before placing the transistors and soldering everything, I use some scotch tape to place the, I believe they're like silicone pads or something like that, some sort of material, to make a better heat transfer between the transistors and the heatsink. So I used a little bit of scotch tape to fix them here on the enclosure, because I believe what we're going to do, we're going to bend the terminals of the transistors. We'll do that in just a second. Place them over here, but not solder them. Place the board inside the enclosure. Fix the transistors with screws here in the enclosure and in the heatsink, and only after that we're going to solder them to the board. So that's the process from what I understood reading the instructions. Now the way you fix the heatsink to the enclosure, you will see in the instructions, but they tell you just to use these screws only in this side, and I believe that's because once we place the board inside, over here you have access and you can put the screws in even after you place the board inside. And what else I wanted to talk about? Oh yeah, you have 4 screws. They're like 6mm screws, and then you have 2 more which are a little bit longer. I'm not sure how long are these 2, but these 2 we will use for the transistors, and the other short one, the other 4, we're going to use them for this for screwing attaching the heatsink to the enclosure. So that's it. All right, let's do this thing. Bend the terminals if I can find the pliers. I forgot where I put them. Right here. Okay, so they say bend the terminals upwards, so that's what I'm going to do. If I break any legs, no problem. I have a couple of spare RF 510s because I wanted to build an RF amplifier myself, but I never did. Okay, this one will do the same. Sorry, my camera is losing focus. So basically we're supposed to place them like this on the board, and now I'm going to turn it around, hold the transistors somehow, place the board in the enclosure. Maybe if I do it this way it's better. Yeah, I did it the wrong way. So I have to put the other 2 screws. No, I have to take, I know what I have to do. I have to take this end back and bring it in from the other side. Okay, we'll do that. Lucky me, I didn't tie this one, because it was just temporary, but I didn't know that I'm going to get to this part. Anyway, it's fun. It was fun building this RF amplifier. I'm learning, but honestly I'm learning a lot more when I'm building the circuits from scratch, and I'm not learning so much when I'm building kits. I'm not sure if you have the same thing, but that's what's happening to me. Okay, so we're going to place it slowly. Oh yeah, of course. I said I'm going to do it the other way. All right, so now I believe I'm going to use my tweezers. Okay, I bring the transistors in the right position, and I believe right now I'm going to have to use the screws and screw the transistors inside. Okay, I'm going to do that off camera, just because I have a weird position and it's hard to film, and also make sure to pay attention to what I'm doing there, and I'll be right back. I'm not sure how well you can see, so I placed 1 screw. I still didn't solder the transistor yet, because we're going to check some stuff in a little bit. Now I'm going to have to do it in this side as well. Now you have this little plastic things. We're going to put the screw through this one like this, and then we're going to put it in place and screw the transistor as tight as possible to the heatsink. Of course, with a good sense so we don't break it, and that's it. Now I'm going to place the back end again in its place, the back plate I should say, and soon we're going to take the multimeter and check to make sure that the transistors don't make any contact with the ground, basically with the case. I don't think they should have any contact with the case, so let's check that first before we're doing any soldering. And once we're doing the soldering, we're pretty much done, and we can turn it on, see if there's any smoke coming out, and if there's no smoke coming out, I believe we can continue doing the tests. Okay, so let's see. Nothing over here, and nothing over here either. Okay, we're good. And these two? Yeah, there's contact over there. Nothing over here. All right, we're good. We can start soldering the transistors back in their place. All right, we finished it. Don't forget, use the brush, clean it up really nice, and we're done. I soldered the transistors in their place. I cut the extra terminals, the little legs. Don't forget to put these other two screws to tie the heatsink to the enclosure. And I believe it's time for the smoke test. I'm just going to clean up the table, take a quick coffee break, and then after that I'm going to come back and do the smoke test. And of course we are going to start testing the power output and so on. How do I put this one? Okay, it goes like this. Well, I'm going to take it out because I have to adjust the biasing of the transistors, but yeah, it looks nice. It's really nice amplifier. It's very tiny. It's excellent. 50 watts CW, good. I really like it. I might end up ordering one for myself as well. Yeah, very nice. Okay, so I guess it's time to tell if it's going to smoke or not. I plugged it into the dummy load. Even when I'm going to do the tests, I'm going to do only short bursts because the heatsink on this one is quite small, so it's not really meant for 50 watts, maybe 20 watts the most. But it should be alright for very short bursts. And I have the plug of the power plugged in. I don't have any RF coming in, and I just realized that I don't have enough coaxial cables to make this test, so I'm going to have to improvise a little bit. But let's turn on the power and let's see if there's smoke coming out or not. Fingers crossed. So far so good. So it's on. There is no smoke coming out. I don't smell anything. I'm powering it with the power supply, 12 volts. Well, I'm guessing this should be okay.